Make it fast and powerful. Make it intelligent and make it learn. Make it analyze and predict. Make it fun and creative. Make it look sharp and gorgeous. Make it friendly, user-friendly. Make it efficient and productive. Make it smart and connected. Make it prevalent and extensive. Make it secure and protected. Make it safer and autonomous. Make it sound clear and pure. Make it speak
and understand.
Make it free, truly wire-free. Make it sweat and stay in shape. Make it move and sense all around you. Make it grow and make it nourishing. Make it all happen with CEVA. CEVA licenses ultra-low power smart sensing and wireless connectivity solutions. CEVA's IP powers more than 10 billion devices worldwide. Dream it and make it with CEVA.
Hi all, thank you for joining the Clear Voice from the Future virtual seminar. My name is Youval Nachum and I am the Product Marketing Manager of CEVA Sound Products. Today I would like to share with you the market trends and the supportive technologies, including a CEVA unique offering towards a voice-centric world. One of the main trends that we see at the sound market is that more and more users are starting to use voice as a user interface. Voice has a lot of advantages. It is an intuitive interface. You don't need to use your hands, no need for line of sight. It is a straightforward control interface. Just say what you want and you get a quick and accurate response that is relevant to your profile. Voice control technologies are mature and can be easily integrated into any appliance. One of the main technologies that is driving the voice as user interface is speech recognition technology. It is started due to real needs at the smart home and the automotive, where you need to keep your eyes on the road and your hands on the steering wheel. Speech recognition applications are mostly based on neural networks technologies and includes wake word detection like Alexa, OK Google, Shaydu. When the system is turned on by voice trigger, the user can control the system with voice commands, pre-configured one, or with the intuitive command using the NLP, natural language processing technologies. When using a speech recognition application at a quiet environment like home or office, when the appliance doesn't have a speaker, a speech recognition engine can do their job very efficiently. At a noisy environment like outdoor or smart TV are more challenging, and we need the support of noise reduction and acoustic echo cancellation technologies. There are more challenges to speech recognition engine. For example, controlling your TV at a crowded living room while everyone is talking. This is where speaker separation technologies can identify the main speaker at the multi-speaker scenarios. The availability of a virtual personal assistant through wireless connections such as Bluetooth or Wi-Fi with low latency significantly improve the experience of the user and encourage him to use a voice control interface. Due to low power processing, voice control appliances can be battery operated, such as smart speaker, headset, smart watches, and therefore much more available for the user. Sound sensing technologies also improve user experience and increase voice interface capabilities. For example, identifying your emotional situation and response accordingly. Active noise control also improves the user experience, allowing the user to communicate by voice without any environmental noise interference. NC can be done by using your headset, for example, or by sitting at your car at your personal audio zone. All these technologies are already adapted at 3 main markets. The early adopter markets for voice as user interface are mobile and wearable, smart home, and automotive, with market forecasts of up to 4 billion audio-related units by 2024. Mobile and wearable market, including the smartphone, headsets, smartwatches, and AR/VR, all these products are usually used for personal usage. Most of the time are carried by the user, held in a short distance from your mouth and connected to the cloud. All these characteristics make your personal portable appliance perfect product for voice control and voice assistant. An example for truly wireless device powered by CEVA is the Google Pixel Buds 2 with integrated voice assistant. The second market is a smart home with a smart speaker, smart TV, and voice-activated home appliances. The first significant adoption of voice assistant at home is related to the smart speaker, a small device, battery operated with microphone speaker and connected to the cloud. You don't need to upgrade any of your existing devices such as a TV or set-top box. This is the reason why the smart speaker created new market and gets ahead with incredible annual growth numbers. Now we see that voice control is spreading to other home appliances such as smart TV, TV remote controller, refrigerator, microwave, and trash cans. The third market is automotive with infotainment during the ride and hands-free voice communication, and the hard regulation forcing you to keep your hand on the steering wheel. Automotive is a challenging environment for voice control. There is a lot of noise, road noise, engine noise, road noise, but the driver desires a hands-free solution, personal audio, and quiet sound per seat. Let's continue with the market trends per product type. I'm sure that each one of you desires a tiny, truly wireless with the ANC and high quality sound. You can see that the headset market forecast is 20% annual growth and 600 million SoC by 2024. At the right side of the slide, you can see a few examples of such truly wireless devices powered by CEVA. One of the main challenges for headset to provide such a user experience is power. You can charge your headset with its case, but it should keep on working for a few hours. Eli Audio that France have just presented and was recently announced brings really good news to this market. It provides a standard truly wireless audio with low power consumption. It brings new features such as audio sharing, where you can simultaneously connect it to your laptop and your smartphone. Audio sharing, for example, we can broadcast this virtual seminar at large screen while many participants can be Bluetooth connected to the screen and enjoy the new and efficient high quality audio codec, the LC3. Since headset is the device with the nearest microphone that we have, it is obvious to use voice control as user interface. You can use gesture, but you need your hands free. And of course, you need to remember the gesture. Is it the right or the left ear? Is it single tap or double tap? Voice trigger and voice command are more intuitive and can be implemented in a headset with a reduced neural network model. The headset structure and location allows the use of sophisticated noise reduction and voice activity detection, what we call VAD technique. For example, in-ear headset is located near the bone of the jaw. It can indicate speech according to the bone vibrations. This sophisticated VAD voice activity detection can improve the power consumption and the noise reduction algorithm performance. There are also other technologies for VAD that are based on speech attributes and neural networks. Another advantage is that the mouth is at a fixed direction relative to the headset microphone, which make it more easy for the noise reduction algorithm to extract the speech from the noise. The comfort of ANC, the ability to enjoy clean sound, voice, or music without the interference of your local noise, make it also a required feature for the truly wireless headset. There are a few methods to implement ANC, and they require different processing power, different number of microphones. Anyhow, all methods require extremely low latency system. User authentication by voice biometry also make the user experience more intuitive and comfort. All your personal setting and voice assistant database is automatically authenticated by recognizing your voice. It's very simple, as it. You don't need any password or something like that. Environmental sensing, the ability to understand the situation according to the sound analysis, provide a set of new interesting features. For example, the noise reduction algorithm can be adaptive according to the environmental noise, or you can be alerted when a siren is played. The next voice control desired wearable is smartwatch. Smartwatches are also becoming voice activated and voice controlled, with market forecast of 10% annual growth and 100,014,000 units by 2024. At the right side of the slide, you can see a few examples of smartwatches powered by CEVA. Smartwatches are battery operated with demands for battery life for days, even weeks. Smartwatches' operational environment is very challenging. It is an outdoor device with a microphone distance and location that is rapidly changing. You're moving your hand. There are up to 2 microphones on the watch, one mic for a single channel noise reduction, or even dual for a beamforming algorithm, which is more sophisticated and bring more performance. User authentication by voice biometry is also applicable for smartwatches with all the advantages. To enhance battery life and sound quality, the emerging LE audio is the right choice also for smartwatches. The next voice controller market is AR/VR. Virtual reality and augmented reality is indeed the next emerging market, with major players such as Facebook, the Horizon, Sony, HTC, with annual growth of 45% and 66 million units by 2024. Audio and voice features for virtual reality are challenging. Although it is a battery-operated device, it requires high-performance audio and voice quality. Voice is part of the virtual scene with augmented sound and directional sound. The speakers are remote and located at the VR frame, which make it more challenging than a headset scenario. The VR includes also multiple microphones on the frame for voice pickup and voice control as part of the virtual scene. VR market is an example of sound and vision technology integration. The same as the next market that I'm going to present, the smart TV. Smart TV and remote controller market is starting to integrate voice control feature either to the TV or to the remote controller, with annual growth of 17% and 276 million units by 2024. At the right side of the slide, you can see, for example, the Samsung QLED TV smart remote controller with a CEVA DSP that is used for voice trigger and voice command. Sound is part of the user experience watching TV. With high-quality multi-stream audio codec, the MS-12, user can enjoy a bass enhancement, speaker tuning, virtual surrounding, and volume leveling, which aims to minimize the advertisement's annoyance. For controlling the TV, we start seeing OEM integrating voice trigger and voice commands into their TV and remote controller. Instead of holding the remote controlling in your hand, you just need to say the right command, or instead for looking for the TV remote controller, you can talk directly to your TV. The TV is in general a multi-mix system with multi-speakers and multi-audio channels. So you need to use multi-mix noise reduction and sophisticated multi-source acoustic echo cancellation that usually have better performance but requires more mix and power. For the remote controller, it is a battery-operated device with single or maximum dual microphones. And it does not have the source of the TV, the sound. So ANC cannot be performed. So it is another challenge for the remote controller. The crowded living room is another challenge using speaker separation technology, identifying the right voice with the commands from all other talkers. TV is one candidate for voice control at a smart home environment. There are also other appliances. Smart home and personal voice assistant are driving the market to integrate voice control SoCs to other appliances at home. The first that makes the revolution is smart speaker with 279 million units and 45% yearly growth by 2024. As presented in the previous slide, smart TV and set-top box are next to come. But there are others, such as personal robotics, vacuum robots with 83 million units and 14% yearly growth by 2024. Refrigerator, washing machine, microwave, trash cans. Most of these devices has no voice capabilities, no speaker, no microphone. Typically, such devices are integrating audio SoC kit with all voice control features. The next market is action and surveillance camera. Action and surveillance camera market also integrates vision and sound capabilities. Many cameras are already voice controlled, such as you can see here on the right side, the GoPro camera powered by CEVA technologies. Such cameras in general are equipped with 1 to up to 4 microphones and 1 or 2 speakers. Sound and video together are part of the scene. Audio and vision analytics based on NN may enable event-driven recordings. The camera can start recording when it detects an event, for example, baby cry, smoke alarm, or specific song. The camera can set the noise reduction profile according to the scene. For example, at car race, the engine sound is really part of the scene. The next market is automotive, where in most cases, engine sound is a noise, excluding sports cars. The automotive market is constantly integrating sound features with annual growth of 3% and 103 million units by 2024. Voice control is highly required in automotive due to the driver convenience and regulations. So infotainment, navigation, climate, car control can be easily operated by voice control. Infotainment is a significant part of the ride. With 3D sound and audio enhancement, driver can improve their driving experience. The automotive environment is noisy and cause to driver fatigue and bad communication. Therefore, automotive environments use lots of technique to remove noise, such as beamforming, road active noise control, wind noise reduction, engine noise reduction. There are even fancy features such as seat sound separation, such as personal audio zone for a quiet zone per seat, or even NN-based sound sensing for identifying siren, brakes, and alarms to support the driving situational awareness. As I mentioned before, the early adapter market for voice control technologies are mobile and wearable, smart home, and automotive. Let's see a diagram for a generic voice-enabled system. Voice-enabled systems are built of audio subsystem, microphones, speakers, analog to digital, digital to analog, and DSP for sound processing and control. The second part is communication, for example, Bluetooth as presented or Wi-Fi. Adding voice user interface to such system has three main models: voice control on the edge, voice control on the cloud, or a hybrid mode. Voice control systems start with always listening mode. And voice activity detection is operated at many levels. For example, using MEM microphones with integrated VAD or hardware-based VAD, or a more sophisticated one is the software-based VAD, which is looking for speech attributes. When the system identifies speech, the input voice may go through pre-processing algorithm for noise reduction and acoustic echo cancellation. Voice trigger, voice command, voice biometering can be operated on the edge device or alternatively on the cloud. The edge device provides low latency since there is no need to go to the cloud, and security since there is no connection. The cloud models offer a robust solution due to communication power and so on, computation capabilities, and it is a central location where you can access to your data from lots of access points. CEVA provides a unique value proposition for all features that we discussed, mainly with CEVA technologies or with the CEVA-wide ecosystem. CEVA unique value proposition sound portfolio is composed of three elements: sound DSP, sound software, and sound AI. CEVA DSP offering includes the CEVA BX for processing all type of application, DSP, control, and AI. For the integration of vision and sound, as we discussed earlier, at smart TV market or action and surveillance cameras market, CEVA offers the SensePro, a high performance sensor hub DSP for sound and vision integration. CEVA software offering including ClearVox for noise reduction, Whisper for speech recognition, SenseLink for it is a glue layer for wireless audio, Bluetooth and sensor fusion, and multiple codecs for audio and voice. CEVA AI offering includes an optimized neural network libraries and the support of TensorFlow Lite for microcontroller. Costa will talk about it in the next session. We already ported the Google demo and the Whisper, our speech recognition engine, on TensorFlow Lite for microcontroller. CEVA Sound portfolio composes a comprehensive wireless audio system as described in the next slide. This is an example of headset building blocks provided by CEVA. The audio subsystem includes the CEVA BX1, a low-power DSP designed for battery-operated device, sound software ClearVox for noise reduction, Whisper for speech recognition. The communication subsystem is based on CEVA Rivera's products, including Bluetooth dual mode and LE audio. The sensor fusion is based on motion engine technologies, and SenseLink, the glue layer connecting all elements into a synchronized system. Let's discuss CEVA Audio DSP in details. The CEVA BX audio and voice DSP family includes two cores, CEVA BX1 and CEVA BX2, with a parallel processing of up to 8 16 by 16 bit max and 4 32 by 32 bits max. CEVA BX pipeline length is 11 stages, allow the use of low power memories for power sensitive design. CEVA BX is designed with embedded audio and voice ISA and improved control processing capabilities with Cormac score of 5.46. In case user has his own payload ISA, the CEVA BX can be efficiently extended with the user functionality using the CEVA Extend. CEVA BX was announced at January 2019 with lots of customer things. It is a modern processor with single instruction multiple data and a variable VLW, a variable length instruction architecture. CEVA BX architecture is scalable. The baseline is marked in dark blue, as you can see here. All other are optional. CEVA BX1 includes single scalar processing unit. The CEVA BX2 includes dual scalar processing unit. The CEVA BX1 support dual 32 by 32 bit max, while CEVA BX2 support one 32 by 32 bits max. There is an option for a single floating point per SPU with half precision, single precision, and dual precision. The instruction cache, data cache, controllers, queue manager, buffer manager can be also added per configuration. Data memory width of the CEVA BX2 is double than CEVA BX1, 128-bit load and 128-bit store in parallel, of course. Both support a loop buffer and a branch predicted buffer to improve the performance and significantly reduce the access to memory. CEVA BX is used for audio and voice processing. For products integrating sound and vision, like smart TV or cameras, CEVA offers the Sense Pro. Sense Pro is targeted for the automotive and surveillance market. It is a powerful voice and vision DSP with embedded fully compatible CEVA BX. It supports a vector unit of a 256 8x8 max. The data memory width is 2024 bits load and 1024 bits store in parallel. All the software that is available for CEVA BX2 is also available for the embedded CEVA BX2 within Sense Pro. CEVA Sound software include over 120 optimized CEVA BX DSP libraries, fully optimized, ClearVox for noise reduction and acoustic echo cancellation, Whisper for speech recognition, audio and voice codecs, SenseLink for contextual awareness, integrating Bluetooth audio and sensor fusion. ClearVox CEVA solution for noise reduction is available in two packages: ClearVox Headset, optimized for headset application, and ClearVox Universal, targeting smart home, surveillance, wearable, and automotive. ClearVox software suite include multi-mic beamforming noise reduction with the support of voice activity detection that indicates voice period and noise period and enables the beamforming to lane the noise. And with the support of DOA, direction of arrival, that detects the direction of the speech. The single channel noise reduction suppress the residual node after the beamforming, or it is used for products with single microphone where beamforming is not applicable. The ClearVox also support mono and stereo acoustic echo cancellation to remove the sound that is produced by the speakers. The output of the ClearVox can be injected to Whisper, CEVA speech recognition engine, and increase the intelligibility in some cases. This is the tandem solution of ClearVox and Whisper, which provides a better performance, high recognition rate with low false acceptance rates at many cases. For example, when the user needs to barge into the system while the speaker is playing music, for example. In this case, we need acoustic echo cancellation, or at a noisy environment where we need the noise reduction algorithm. The tandem solution ensures minimal computation resources and power consumption, since we reuse the memory and internal function. ClearVox and Whisper are provided from a single source by CEVA with the best tuning for high recognition rate in noisy environment, in compared to other solutions where both engines are provided from different vendors. Both ClearVox and Whisper are provided with PC evaluation tool. ClearVox PC evaluation tool allows to evaluate the ClearVox in the pre-sale stage. You can inject your recording into the ClearVox, Configure it according to the system configuration and your subjective observation and get the best results. All software modules can be enabled, disabled. You can listen to the output of the recording for subjective analysis or use ClearVox output as the input for a whisper evaluation. To connect all the elements that we discussed, DSP, audio software, a sensor fusion, and Bluetooth, we need SenseLink, the wireless audio system glue layer. SenseLink platform connecting all sensor and processing elements, CPU for sensor fusion, DSP for audio and voice processing, and connectivity modules. SenseLink software modules include the host framework with the reference application provided by CEVA, multiple ready-to-use optional plugins such as DSP libraries, NN libraries, ClearVox, Whisper, and Motion Engine. The user can also have his own plugin for specific proprietary function. CEVA also provides more than 150 audio and voice software codecs, fully optimized. Voice codecs such as EVS for smartphone, AMR for narrowband IoT, Opus for cloud connectivity, and SBC and MSBC for voice communication over Bluetooth. CEVA also provides a new LC3 LE audio codec directly from CEVA, implemented from official Fraunhofer reference code. CEVA is Dolby certified, providing multiple Dolby codecs such as Atmos and MS-12 for smart TV. Just for the summary, I would like to consolidate all technologies, all CEVA's technologies, behind voice as user interface and more. CEVA provides an holistic solution for sound market, including DSP software, sound network support, sensing glue layer, and extensive ecosystem for additional software modules. Thank you all for joining Clear Voice from the Future virtual seminar.